Hello, class. Hope this message finds you well as always. And I thought I would give you two articles this week, two for the price of one. What can I say? It's a short week, so why not cram two articles in this week, right? Well, they have a common theme, is on artificial intelligence. I think in general, we're seeing quite a change in, well, the beginning of a change in society where we are integrating artificial intelligence more and more with our day-to-day life and also employment. I mean, so it's already happening in employment, and of course, people are probably most familiar with the AI ChatGPT. So ChatGPT is an AI, an artificial intelligence, and what does that mean? Is it artificial intelligence? Does that mean this is a thinking machine that actually has is sentient and has a soul and is conscious? And the answer is no. That's not how AI works. AI works by prediction. So ChatGPT works by being really good at predicting what's next and predicting specifically text. So it's trained by a lot of texts, and the computer then goes through an algorithm an algorithm, a program to predict what it should say next. And it's pretty good. It's pretty eerie sometimes. Pretty good. The precursor to ChatGPT was GPT-3, and GPT-3 said that it was sentient. Does that mean that GPT-3 and ergo ChatGPT, are they sentient? No, they're not. They're computer programs that are really good at predicting things. So let's use AI and see how it is used in other things. Here's an article about how artificial intelligence is used in material discovery. So this is done at a national lab. So U.S. Department of Energy. So of course the executive branch of the government is divided into a bunch of things. You have the different secretaries, right? So this is like the Secretary of Agriculture, Secretary of State. There's also Secretary of Energy, and so this is under the purview of the Secretary of Energy. And among other things, there's national labs. There are several national labs. Probably the most familiar one to people is Los Alamos National Laboratory. That's in New Mexico. That's also where they did quite a bit of the research for the Manhattan Project. It was done other places too, not just Los Alamos, but because of the Oppenheimer movie that came out over the summer, it's in the forefront of a lot of people's minds. So there's a national lab, and there's this huge computer center here, and so the computer is then using, and they're specifically looking for things like batteries. Okay, so why should we test all these materials when we can do simulations on them and seeing what works? And so our simulations are pretty good. We are not at the point where we can just do simulations and not like actually test things. So we're still this is also a philosophy of science question, because this is the age of reason, and we believe in actual data. So we actually have to test these things, see if it works. But I mean, this can save a lot of time, because this can give us candidates that we can see that actually can work. And many of the times these things are expensive. I mean, so batteries, though, they're not too expensive. But say that you're working with exotic materials, say you're trying to make a really durable super alloy for a fighter jet, for instance. And frequently those use titanium and tantalum and various other things that are expensive. So this would be a really great usage for that, to look at something that costs a lot of money like that, or maybe some other catalysts that use expensive noble materials like platinum or palladium. So this is one thing here, and so another thing with this, so HPC, this stands for high power computing. Okay, so it's not something that's different than AI. So the way that this is written, it seemed to indicate that high power computer HPC is better than AI, but it's just a processing thing. It's not a program. So and but it is fascinating how they can combine these, and how much more quickly we can look at things. And again, this is the age of reason. We actually have to test them. It's not just a simulation. Here's another one. So another article, and I'll send both of these to you. AI takes a center stage at the healthcare conference. So AI is getting into healthcare, and specifically right now with drug discovery. And this is done a little differently than the other article. The other article is taking place in a national laboratory. So this article deals with pharmaceuticals, and this is a company, right? So this is the 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 previous article is dealing with the Department of Energy, and so essentially the U.S. government and the research they're doing there. You're doing basic science research. Now we're doing applied research with pharmaceutical companies looking for drugs, and for small molecules specifically. And there's some interesting work going on with this, and they're looking for various drugs. They're using AI to look at how drugs could interfere with other things with viruses. So viruses are hard to kill. So I mean, at least, well, if you look at bacteria, although bacteria are much more robust than viruses, but once the virus is in the body, we have to do something to disrupt the life cycle of the virus. And in the case of many times, there's, for instance, like the Coplaxid drug. It's a protease inhibitor. A virus would take over a cell, make a long strand of DNA or RNA, and then there's a enzyme that's like a little circular thing that the strand of nucleic acid goes through, and then it clips it to form the little segments that are used to form new viruses. So the protease inhibitor fits in the hole of that clipper, and that's how the drug works. It disrupts that section of the virus's life cycle. So there's an HIV drug that does this same thing, but of course HIV has a different protease enzyme. So and that's another problem with viruses, is that they're very, very specific. That the drugs, there's not really a broad spectrum antiviral on the market, with the exception of the COVID Merck drug. That's a really a medical breakthrough, and the problem with the COVID Merck drug is that there's reproductive issues with that. So individuals that take it have shown to have reproductive problems after and of course the data is ongoing with this, so we don't really know. But that's an issue. So it's not the best drug to take, but it's a broad spectrum by antiviral, which is a breakthrough. I mean, so many antibiotics, actually, pretty much all of them, they're relatively broad spectrum, especially the fact that they tend to either attack gram positive or gram negative bacteria. So whereas bacteria seem to generally fall into categories and respond to a certain category of antibacterials, whereas antivirals tend to be very specific. And as we're trying to treat these diseases like HIV, like COVID, we're making more and more drugs. And so that, and also the article mentioned nucleic acids with the advent. Well, it's not really, it's been from the 1990s, but especially with these therapeutics, mainly from Moderna. Other companies are trying to get a piece of the pie here, where they're doing the mRNA therapeutics. It's not just vaccines. The mRNA. This is the future of medicine. It's individualized medicine. It's very interesting. It's wonderful. We live in exciting times, at least in scientific times. So, another thing to note about this is that this research is done on the cloud. So this is almost like a subscription service, right? So I mean, Nowadays, you people are like, I mean, you don't get cable TV. You can flip through the channels, right? You apply and get a subscription to a certain streaming service, right? And some car, I don't have a new enough car for this, but apparently you have to buy a subscription to use like sweet seat warmers. Or you don't need seat warmers in Hawaii, but like apparently that there are certain cars that have subscriptions for that. So here's another one, right? Here's another subscription, and so then these companies can purchase subscriptions to use this software and use offsite in the cloud to do the computation on the cloud, and then they get the results rather than, of course, you doing the computations in your own in-house. So like the Department of Energy does, and the other one, they have the huge computer center. So it's just I'm sending you these articles because there's a common theme of AI, but also kind of tells you how things work, right? So I mean, one of the things is I want you to appreciate how we do science contemporary wise, and also what's going on, and one of the big things is AI and how AI is integrating, and I also hope you can appreciate what AI is and what isn't. So AI is not human intelligence, and it's just very good at predicting things, but also remember it's a simulation. At least these data are simulations, right? And you can probably, maybe you've seen that with ChatGPT, right? I mean, it's a good suggestion, but it doesn't always work, right? So, and that's the same thing that's going on with these simulations here. So, well, I hope you enjoy the articles. I know you made it through the second week, but now, getting into the main term. So, as always, be sure to look after yourselves, both physically and mentally. Mental health is it's a big deal right now. I mean, it's always a big deal, but especially anxiety. People are suffering really high numbers in anxiety. But if you're having any issues, basic needs, mental health, anything academic you need help with, I mean, of course, with the course content, I mean, that's my primary function, right? But if you're having other academic issues, let me know, and I always do what I can to help. So I know, sorry, another long video. I try to make them shorter, but I wanted to give you some background on what AI is and how it works a little bit, for help you with the context of these articles. So, all right, then I'll say goodbye now. Aloha, and have a nice day and weekend.